Hello and welcome to the coding walkthrough video for prototype 0.4. Now there's quite a lot of new stuff in this prototype, and not only is it new, it's cool. The big thing of course this week was gravity. So if I go into the scene view here, what we've got, I know, exciting, right, is 4 planetary bodies, designs courtesy of Josh, attached to the placeholder sun because he hasn't quite got around to designing that yet, and they all rotate and orbit around the sun. Pretty cool stuff. Also this week we've got a map, a brand new map in the game, as well as a tether between the ship and the player, and various other cool bits and pieces. I did a little trailer there for what you're going to see in the video. Did you like that? Thought I'd try it out. But yeah, so what I'll do now is just walk you through the mechanics in action, and then obviously the C# code behind them. So let's go into that right now. Alright, so if we have a look here, hop into the ship and blast off. Still got the scrolling in, zooming in and out function that you saw last week. And what we'll do is we'll just press M and open the game's map. Now as you can see, the player has now been replaced by a triangle, and there is a line coming out of them. This line represents the current direction that the player is moving in. So if I start holding W rather, and moving that way, the line moves downwards because we are burning this way and changing the direction of our movement. This is basically a beta velocity vector prediction thing. Or, well, actually it may end up being the full thing. It depends how difficult vector prediction is to code. It's certainly been a difficult one this week. If you read the weekly walkthrough that I posted earlier, you'll find out why. But yeah, so what we'll do, because we're at a high enough velocity now, we'll just speed up time. Yeah, we've got that in the game too. Because orbits can be a little bit boring sometimes. Speed up time. Time scale is just there actually. And oh, I've just realised you can't actually see my cursor. There we go. You should be able to see it now. Ooh, so many things happening at once. The time scale is there, and if we drop it down to 0, 1, there we go. Time scale there. If we drop it down to 1, you can see these trails. Now these trails are being left by the planets that have orbited around and now off screen up there. And that's the sun there, obviously. And if you look there really closely, you can just about see the fuel cloud and asteroids. This is zoomed out to 1000f in orthographic size, so we're very far out. Alright, what we're going to do is just bump that timescale again so we can see the planets in action. Yeah, there we go. There is Elcaloda, the Mars-like planet. Now you may be wondering, what are these loops? As you can see here, if you look very closely, you can see the moon of Elcaloda. And as it goes round said planet, it does a little rotation, which looks really cool. And, well, it is cool. And as you can see as well, each planet has one of these lines attached to it. It's the same deal as the player's one. It basically tells you where the planet is going in relation to, well, direction, really. And let's just see if we can... Ooh, no, we missed it. I was going to see if I could do a little landing there for you. Not to worry. We're still flying half a ship. Come on. No. Catch up. Ooh, and... Oh, did you see that? We skimmed it. Oh, bounced off. Yeah, gravity is a little balked. It's functional. Well, it's functional in orbits, not so much in colliding. Oh, there we go. Bang. We've landed. Yeah, the circle collider's a bit iffy, that's why we're going in and out there. There we go, we have now landed on a planet. Hold the applause. But yeah, so that is... Oh, I should point out, actually. I'll just reset the game because it's easier. If you press T, there's now a visible tether between the ship and the astronaut. doesn't actually do anything physically. It's just a line between the ship and the player. So if it goes off screen, you don't know where it is. You can just remote control it and get it to come towards you. Stupid ship, come here. But yeah, it's basically a little, if you lose your ship, then it's easily found again mechanic. Let me toggle that off because we're close by, and hop right back in the ship. And yeah, let's just pretend that I hopped right back in the ship and no problems were had there. But yeah, so those are the new mechanics of this prototype, and what I'll do now is go into the code behind them. So the first and obviously biggest thing we've added in the prototype is the gravity, and that's done via this orbit system script. So here we set a bunch of things to start. I've decided I'm going to go through these as they appear in scripts rather than going through them at the start because it's just easier that way. So orbiter is the thing that's orbiting whatever the object is, and the orbitee is the source of the gravity, the thing that the orbiter is rotating around, basically. So here we grab the rigid body of the orbiter, the rigid body of the thing that's rotating around the orbitee, and we also grab its mass from the rigid body, and we also grab the orbitee's mass. Hello, phone. And we also grab the velocity of the orbiting game object there. So in this fixed update here, we set the current velocity, which is that float there. Yeah, we set that to the velocity.magnitude of the orbiting game object. We then create a new vector3 called diff and set it to basically the orbitee's transform position, i.e. the transform position of the game object that we're orbiting around, minus this transform position, which basically means minus the transform position of whatever this script is attached to, which is normally the orbiter. So basically the sun's transform position minus the planet's transform position. That's an easier way of putting it. And then this vector3 that we set up here is just the diff, this new vector3 normalized. So then we calculate our gravitational force, which is basically the mass of the planet times, the mass of the sun times the mass of the planet times the gravitational constant, which is a float that we set in the Unity editor, which I'll show you in a second, divided by the square magnitude of the diff vector3 that we set earlier. Then, finally, just to finish off, we add a force to this, which is usually the planet rotating around the orbitee, which is in the direction, the vector3 of, this, which is diff.normalized, which we set earlier, times the gravitational force, which we set here. So what that basically does is adds a force towards the sun, times by all of these different variables. And what that basically means, hold on, if I just show you this. Yeah, so the gravitational constant here is set to 25,000. And what that basically means is that if we go into here, it's in maximize, we don't want that. Come on. Unity, why? I do all these nice things for you, and this is how you reward me. Let me click on the scene. Please bear with us, we're having some technical issues. There we go. Right, so as you can see, the planets are moving in correlation, is that the right word? In accordance with the orbit system script. So basically, the direction, because it's moving towards, it's just got a starting velocity, which I'll explain in a second, in the direction of the game object times by the gravitational force that I showed you earlier. Now, the planets also have a starting velocity, which is set here, initial speed. Should I hit pause? Where is that set? Oh no, that's a ship, that's why. Did wonder. Yep, the starting velocity of it is here. Yeah, so the initial speed of the El Caloda planet is 80. So that basically means when the game starts, the Alcaloda down here is moving that way at a speed of 80. That's to give it a bit of a push start so that it actually starts rotating around, because if you didn't do that, then it would just move straight forward and just get eaten by the sun. So it's got to have a force moving that way to the right so that it actually then loops round and starts orbiting. So yeah, that's how the orbit system works. Pretty cool stuff. So we'll move on to VD. I have no idea why I named it that, but yeah. This is the script that... Oh, it's still playing, how convenient. This is the script that draws these lines here, the predicting velocity lines. It does that by getting several different variables. Like it gets gravity here, which is direction times gravitational force, which is exactly how the orbit system does it, direction is gravitational force. So it just gets the same vector 3 from that. It also gets the player's current velocity and their current position. It then predicts their next position by creating a new vector 3 and adding the player's current velocity and current gravity to it, and normalizing it times it by 300 to make the line longer and more visible. Basically, it's predicting the player's next position by adding the gravitational force and current velocity to it. So essentially, well, it's a rough prediction, but predicting where they will be if they continue on their current velocity and gravity. Which is why, if we go into the game and get in the ship, you'll notice here it's predicting it while velocity is a certain thing. So while you go, if you go that way, it changes based on your velocity and the gravity. It's basically like a simpler vector prediction. I call it velocity prediction because it's easier. So we do these several times in order to get a more accurate representation of where we're going. Store these in a array here, vector 3 array, and then we go down here where we set the positions of the line, which is a line renderer that we've got up here, which is a line, calling a line renderer that's attached to each planet and the player. Here it's a physical game object. It sets the positions of the line renderer to the positions all established here, which basically just, I should point these out, which just call the predicted positions as we've set up here. Sets the width of the line and the length of it in correlation with the positions. And so that's how it draws the line. And then if the isMap boolean is true, if the player is in the map, then set that line to true. And also set the trail renderer to true. Which if I show you... well, I mean, you've seen it already. Each of the planets also has a trail renderer. Don't hit that. Oh. Well, you saw it anyway. The blue line's coming out of the back of the planets. And that's all done by this trail renderer here, which, like the name suggests, it renders a trail behind the game object. And so all this script does is if the isMap boolean is true, if the player is in the map, enable the line renderer and the trail renderer. So that it's not running all the time, so it's optimization and performance fix in there, really. And yeah, that is the vector prediction mechanic, or velocity prediction, I should say. So let's move on to the tether script, which is a pretty simple one, really. If you're pressing the T key and isTether is false, then isTether is true. Otherwise, if you're pressing the T key and isTether is true, then isTether is false. Again, simple. And if isTether is true, then draw a line between the player and the ship. So what that basically means is you can toggle the tether line via the T key, as I'm doing here. A line between the player and the ship so that you can see the ship at all times, where it is, and such. So yeah, that's a really simple script. It doesn't take much. And this next one is even simpler. I don't know what's up with the moons. I think it's something to do with the fact that this solar system is miniaturized in comparison to real life, whereas the gravity isn't so much. All the numbers are wacky, basically, but the moons don't behave properly when you try to get them to orbit the planets in the same way that the planets orbit the sun. So the orbit system script doesn't work on them. They go all weird and either fly off or just crash into the planets repeatedly. I don't know why, but Josh suggested that we just put them on rails. So, well, rails quotation marks. So that's what we've done. So rather than have them affected by gravity, we just have a simple transform rotate around that just transforms, just rotates the moons around the planet that it's attached to, times vector 3 dot forward, which is on the x-axis, times by a float of 8, times time dot delta time, and this thing here just sets their transform position minus the planet's one dot normalize, so that basically means that they stay close to their corresponding planets at all times, and it basically means they're on rails, so they just rotate. In fact, I'll do speed up time so you can see it a bit better. There you go. So it's rotating around all times. It's not actually affected by gravity, which is a bit of a shame. I would have liked it to be realistic, but can't have everything really. And also, I think we could have done it, but it's a lot of number tweaking, and it's not really worth the time it takes, to be honest, because the resulting effect is the same. It's still going to rotate around the planet, so why not just do a really simple function rather than spending ages trying to work out the exact gravitational numbers that will need to rotate have a stable orbit. That was our thoughts anyway, so that's what we went with. Moving on, the camera controller script. So you might have noticed if you watched last week's coding walkthrough that this was all commented out. It's back now because we re-enabled the map. So basically, if you press the M key, then is normal view the boolean, it's a boolean, is set to false. The orthographic size is set to 15,000. I thought it was 8,000. Whoops, I need to change that. Change it in the patch notes because I wrote 1,000. But yeah, so zooms the camera way out. Sets the ismap boolean to true, which then starts using the fuel as I've established in previous prototypes. Sets the indicator on locator beacon game objects to true, and also sets the line renderer of the ship to true. Yeah. So it zooms out essentially. I'll just show you again here. Getting into the ship, it zooms out and replaces the ship game object with this triangle because you can't see the ship when it's this far zoomed out because it's so small. Oh, we've crashed. That's why. I was like, what's going on there? But we've done a crash. And yes, that is all that's been done there, I think. Oh no, there's this as well. This is pretty simple too. If you press the up arrow key, then the time scale is up by 1. If you press down, then it's down by 1. Current time scale equals time. Oh, that's something else. Yeah. Yeah, all that basically means, as I showed you earlier, is if you can't see it, but if you press the up arrow key, it increases how quickly time goes past, and if you press the down arrow key, it decreases it. Yeah, that's just because orbiting can get boring and long sometimes, so you can kind of skip it. Kerbal Space Program has a similar mechanic for exactly the same reason. And then the last piece of coding editing we've done this week has been to the speed GUI, the GUI of the game. This is really simple. All it does is just add the timescale to the GUI at the bottom. That's it. That's all it does. And yeah, that is pretty much it. Most of the coding this week, honestly, has been tweaking numbers with gravity and fiddling with the vector prediction, which ultimately didn't work quite as we wanted it to, although we did get velocity prediction out of it, so that was something. But yeah, we've done a lot of editing and fiddling and refining this week, and tweaking numbers rather than actual code, which is why this walkthrough is shorter than last week's. But yeah, that's it. I hope you enjoyed, and I'll see you in the next